morning, everyone. Welcome to Mathematics 4, Quarter 2, Week number 2. So, our learning competency for today's activity. At the end of the lesson, you should be able to write a number as a product of its prime factor and find the GCF and LCM of two numbers. So, let's proceed to lesson number 3, prime factorization. So, these are the two methods to find a prime factorization of a number using continuous division and factor tree. So, let's start with a continuous division. The number is divided by itself. The number is divided by its prime factor. The division continues until the quotient is a prime number. So this would be the process in continuous division. So let's have an example to further analyze how to use continuous division. Express prime factor of 36. So this would be the given number 36. This would be the continuous division bar. So let's divide this one using a prime number. So think a prime number that would be multiple of or can be a factor of 36. So let's start with 2. 36 divided by 2, the quotient would be 18. So again, let's think a number that can be divided by 18. It's 6, a prime number. So 18 divided by 2 is 9. Again, think a prime number that can be divisible by 9. It's 3. Very good. So 9 divided by 3, the product would be, the quotient would be 3. And then 3 divided by 3, the answer is 1. So this would be the continuous division. So the factors of 36 are 1 multiplied by 3, multiplied by 3, multiplied by 2, multiplied by 2. Again, let's have an example to further analyze continuous division. Express a prime factor of 26. So 26, use the continuous division bar. So let's divide this one to 2. 26 divided by 2, the quotient would be 13. And then what would be the prime number that would be divisible or factor of 13 is 13. So 13 divided by 13 is 1. So the factors of 26 are 1 times 2 times 3. Okay, so another example is 102. 102, long division, continuous division bar. So divided by 2, we have 51, and then 51, it can be divisible by 17. So 51 divided by 17, the quotient is 3. And then 3 divided by 3, the answer is 1. So the factors of the prime factors of 102 are 1 times 2 times 3 times 17. Okay, so how about 42? We have using factor 3. So we have 42. Think of a factor of 42. The first one is a prime number, and the second one is either a prime or a composite. So 2. So 42 divided by 2, the answer is 21. 21 is a composite number. And then again, use the factor 3. What would be the factor of 21? We have 3 and 7. So 3 and 7 now are prime numbers. So this would be the clue that you're going to stop using factor 3. So these are the factors, prime factors of 42. So 2 multiplied by 3 multiplied by 7. Again, let's have an example using factor 3. So the prime factor of 98 would be 98. What would be the factor? We have 2 and 49. 2 is a prime number and 49 is a composite number. And how about 49? We have 7 multiplied by 7. So 7 and 7 now are both prime numbers. So this time it, it this will be our prime factors. So 2 multiplied by 7 multiplied by 7. So I hope you already know how to use continuous division and factor 3 in prime factorization. Okay, let's proceed in lesson number 4. Find the GCF and the LCM of two number. When we say GCF, it is a greatest common factor, and LCM is a least common multiple. So there are three ways to find GCF and LCM. The first one is a listing method, and the second one is a prime factorization, and the last one is using continuous division. So let's have an example. Find the greatest common factor of 8 and 12. Again, greatest common factor. It involves a factors. So let's use the three ways: listing method, prime factorization, and continuous division. So 8 and 12. So these are the factors of 8: 1, 2, 4, and 8. The factors of 12 are 1, 2, 3, 4, 6, and 12. What would be the common factor between 8 and 12? Very good. Grade 4 pupils. The common factor would be 4. So the GCF of 8 and 12 is 4. How about using prime factorization? So using prime factorization, the prime factors of 8 is 2 multiplied by 2 multiplied by 2. And the prime factors of 12 is 2 multiplied by 2 multiplied by 3. So the common prime factors in 8 and 12 is 2 and 2. So we have 2 multiplied by 2. The product is 4. So the GCF is 4. Now using continuous division, we have 8 and 12 using continuous division bar. So divided by 2, we have 4 and 6. Divided by 2, we have 2 and 3. So the GCF is 2 multiplied by 2. The product is 4. So the GCF is 4. Now, this time we're going to find the least common multiple of 8 and 12. Again, multiple. So again, using listing method, prime factorization, continuous division. So these are the multiples of 8. 8, 16, 24, 32, and 12 is 12, 24, 36, 48. So the common multiple of 8 and 12 is 24. So So the LCM rather, is 24. How about the prime factor using prime factorization? We have 8, we have 2 times 2 times 2. So we have in 12 is 2 times 2 times 3. So we have a common, and the 2 part, we have 2 multiplied by 2 multiplied by 2 multiplied by 3. The product would be 24. So this would be LCM rather. Okay. How about using continuous division bar? So divided by 2, divided by 2, and this would be the part of LCM. So we have 2 multiplied by 2 multiplied by 2 multiplied by 3. The product would be 24. So this would be the LCM of 8 and 12. So let's have an example to further analyze what do you mean by LCM and GCF. So find the LCM of given number 15 and 45. So using uh, continuous division, we have 15 and 45. We have the prime factors of common between 15 and 45 is 5. So 15 divided by 5 is 3. 45 divided by 5 is 9. And then the common factor or the prime number that common between 3 and 9 is 3. 3 divided by 3 is 1. And then 9 divided by 3 is 3. So the LCM would be 5 times 3 times 1 times 3. So the LCM would be 45. And find the LCM of 16 and 20. So using continuous division, we have 4. So the common factor between 20 and 16 is 4. So 16 divided by 4 is 4. 20 divided by 4 is 5. Then this would be the LCM of 16 and 20. So 4 times 4 is 16 times 5 is 80. How about sample number 3? Find the GCF of the given number 21 and 49. So 21 and 49, the common between factor between 21 and 49 is 7. So 21 divided by 7 is 3. 49 divided by 7 is 7. So 3 and 7 has no common factor because they are both prime numbers. So the answer would be 7. Okay, next. Find the GCF of 27 and 45. So the common between 27 and 45 is 9. 27 divided by 9 is 3. 45 divided by 9 is 5. So 3 and 5 are both a prime number. So that the answer would be 9. So the GCF is 9. So I hope you already know how to find the GCF and LCM of the given number. So for your reminders for today activity, so answer assessment on page 9 and assessment on page 11 of your self-learning module. So that's all for today, grade 4 pupils. I hope you already know how to find the LCM and GCF of the given number and using continuous and prime using factor 3 and prime factorization. Uh, that's all for today. Thank you and God bless.